Assalamualaikum warahmatullahi wabarakatuh. My name is Farid Hasmi bin Muhammad Nordin. Today we're gonna present about our project, which is automatic storage rack. First, we go to background. Lately, we found out that thievery always happen at the mosque, and also the storage at the mosque is also limited. Therefore, we propose to build an automatic storage that using ASRS system by using RFID card. Next, we move on to the next slide. Uh, this is the evidence that people always complain that their belonging got stolen. Got stolen. Many UIA students, you can see that complain about their belonging got stolen. The product literature that we found that ASRS is used to placing and retrieving the loads. It also can move at three-dimensional lattice structures. It is also more efficient and more faster.
Wabarakatuh. My name is Nurul Alia Sofia binti Syaimi and my matric number is 171948. Now I will explain about technical literature. The concept that we found is automatic storage retrieval system ASRS, and there are four types of ASRS, which are unit load, mini load, deep lane, and man on board. And we use mini load because our product only handles small loads, and the availability of space at most is limited, and we enclose for security of items stored. Next is patent literature, and the patent name is automatic storage retrieval apparatus for article, and these are the design that they have used. In this patent is adjustable storage rack, and it use forklift mechanism. Next is customer survey, where 53.1% strongly agree that to be cheap, 68.8% strongly agree about safety, 59.4% agree about user friendly, 71.8% agree about low probability jamming method, and 59.4% agree about the time taken retrieve method, 59.4% neutral about high capacity, 65.6% disagree about 5-year lifetime, 50% strongly disagree about operate 24 hours, 59.4% neutral about less power consumption, 59.4% agree about key.
Move on to a problem statement. People going to the mosque need to keep their belongings through a keyless and systematic storage rack because there is no secure storage rack provided at the mosque. And the objective of our project is to improvise the current storage at mosque area by using ASRS system. And the next one is to minimize thievery occurs at the mosque area. And the next one is to attract people to performing congregational prayer at the mosque without concerning about belonging being stolen. And the last one is to provide more capacity to the current storage without using more space.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris bin Dawtahi. So I'll continue about concept selection. We have come up with 4 different designs for the automatic storage rack. This is the first design. The rack will rotate to keep the shoes or the belonging in the rack by rotating by level. And this is design 2. The difference is the amount of belonging that can keep by one level is less than the first design. Then the third design is almost the same with to design 4, but the difference is the amount of shoes that can be stored is higher than to design before. And the last design we use ASRS system, which is the platform that can be stored, that can store the item will move horizontally for the column and move vertically for the row of the right here to store the items.
Next is vector per chart. These are the criteria that we want, which is cost, weight, size, capacity, time to process, power consumption, and complexity. And we use concept 1 as the datum after calculated, and design number 4 has the highest number.
So we come up with the design 4 as our design after the part chart. So this is the actual view how our product, which is a automatic storage rack. It have two different rack to store, left and right, and this is the exploded view, and this is the inside view, and we see here how the main platform move horizontally and vertically to keep the box in the rack to store the item. Next, the engineering characteristic that we need to take care of our product. First is dimension of storage box. The dimension should be adequate to store the large items in the rack. Next is the operation speed. The operation speed should be fast to store and retrieve the items. Next is the torque motor. Torque should be able to store the item that we need to store. And then the cost should be not too expensive for the user to use. Next, the power consumption should be enough for supplying for our automatic storage rack. Then next is the sensor sensitivity. The sensor should be sensitive for the platform to move and save the item in the correct place. And then the jam probability should be avoided by our products. And the life expectancy should be long because the automatic storage rack will be used for 24 hours. Then the weight should be not too heavy because because it will ease the user to change the place for the rack. And then the material toughness should be strong because we need to keep the item safely from the thief.
So product design specification is where the first one is the weight of our product must be medium, and the second one is operating speed, also medium, and the third one is operating times, which is 24 hours, voltage low, capacity. We know that we must provide large space to get more capacity. And next one is accuracy. The accuracy of our product must be high, so no more problem occur in the future. And next one is the lifespan of the product must be high, and the safety aspect that we put on our product is RFID card. And the next one is performance, must be quick response and high reliability, so that our product is efficient. And next one is special features, which is keyless, and we also use IoT, Internet of Things. That's all.
And this is our HOQ, and it can be seen that the most important thing is cost and the least important thing is dimension.
Okay, next I will explain about the modeling of the system and also the calculation. For the modeling, first we try to model how the main platform move horizontally and vertically to keep the item in the storage rack. First, for the horizontal axis, we find the torque required, and this is after we derive all the formula, and then you will get this formula for the horizontal axis. Same goes to vertical axis. We also derive same as horizontal axis, and this is the formula for the vertical axis. Then we calculate the torque needed for the motor to rotate and to move the main platform. First, we determine the mass of the load. The maximum mass that the platform need to move is 5 kilogram, and the mass of the bed is 0.5 kilograms. And the radius of the drive pulley is 0.0125 meter. For the horizontal axis, we got the torque needed is 0.6 Newton meter, and also for the vertical axis also 0.613 Newton meter, because we assume that both of the axis need a same amount of maximum load, which is 5 kilogram. Okay, next we calculate how to choose a motor selection for back driver. First, same as before, the maximum load mass that we need to move is 5 kg, and the cylinder mass 1 and mass 2, which are left and right here, is 0.1 kg, and the diameter of cylinder left and right also the same, which are 25 mm. And then the mass of timing belt can be neglected because I think it is not too heavy for the motor to rotate. Next, we calculate the motor shaft conversion load of inertia. Then we get 7.96 times 10 to the power of 94 kg/meter squared. Then calculate the load torque calculation, which is 0.613 Newton meter, and then calculation of rotation speed, which is 1440 rpm. Then motor stabilization, we use motor 1 Newton meter times 0.8, we get higher than 0.6131, which is the load torque calculation here. So we can use 1 Newton meter motor. Next, then we calculate the acceleration and deflection torque. Then we get 0.612, and then lastly calculation of maximum momentary torque, effective torque. Then the total RMS torque is 0.6496 Newton meter. So with this value, we use the motor that we choose is Faulhaber 3863HO24C. So this is the data sheet of the motor for Faulhaber 3863HO24C. We see here the torque for the motor is milli-Newton meter, so it is more than 1 Newton meter that we need. So I think it's powerful to move the 5 kilograms load. And this also the rate torque and the rate current needed, and also the rate speed 5510 and 10 per minute. Next, we calculate how to determine the radius of cylinder beam. So we use aluminum alloy as a beam to support the main platform that will move in the horizontal axis. So this is a two beam that we will use to support the platform to move in the horizontal axis. So same as before, maximum load mass is 5 kg. And then the allowable normal and shear stress we find from the data here, which is the yield strength and the shear strength of the aluminum beam is 276 megapascal, and shear strength is 207 megapascal. And then the length of the cylinder beam is, the length here from here is 1.9 meter. And for the calculation, we assume that we use only one aluminum cylinder beam only here we assume here. Okay, then for the calculation, we calculate the point which are the maximum shear force and also the maximum bending moment happen. So for the maximum shear force should be at the end of the beam, and the maximum bending moment should be at the middle of the beam. For the calculation, we only calculate the static force, which means that the platform will stop here at the end of the beam and also at the middle of the beam. Why we choose these 2 points? Because at the end of the beam should be the maximum shear force, and then the middle of the beam should be the maximum bending moment. So based on these 2 points, we need to calculate and find the minimum of the radius that is required to support the 5 kg load on the beam. So first we find the AY, BY force, and then we draw the shear force and the bending moment diagram here, and then we find the maximum shear force and maximum bending moment to find the minimum aluminum cylinder based on these 2 points. So at this point at the end of the beam, the maximum bending moment, the radius required is 3.228 times 10 to the power of -3. And then for the maximum shear force, the radius required is 2.217 times 10 of negative 4. So we choose this radius because it's larger than this, so it should be the minimum radius required for the beam. But we cannot stop here, we also need to find for the maximum bending moment at the middle of the beam. Same as before, we calculate and draw the shear and moment diagram, and then for the maximum bending moment, the radius should be 4.75 times 10 to the power negative 3, and the maximum shear stress, and then for the radius that required is 2.378 times 10 to the power of negative 4. So from all of these four value of radius, we take the highest radius because it is the minimum radius that required to support the beam. So we choose 4.75 times 10 to the power of negative 3 meter as the radius for our beam. But remember that we assume this is only one beam, so we use two beams, so it should be enough to support our platform more than 5 kg. So at the mechanical workshop, we use 0.03 meter diameter to support maximum 5 kg of the platform. So it is more than enough to support our load.
Moving on to the selection for timing belt. Firstly, we calculate the pitch length. The C, large diameter, and the small diameter are determined by us based on our equipment, and the pitch length that we get is 3957.08 mm, but it needed to be at by 45.72 mm due to the B type belt section, as we used a medium horsepower application. Next is the allowable horsepower, which are 0.6821 horsepower, and design horsepower 0.3862 horsepower. Then is the centrifugal tension, and we have determined the V is 1200, and we get the centrifugal tension is 0.41057 Newton, and the largest tension is 2669.88 Newton, and the least tension is 86.03 Newton, and the initial tension is 177.3 Newton for the timing belt. And lastly is the calculation for selection for inductive proximity sensor, where in this calculation we are calculating the correction of distance sensor. So the model that we use is LJ12A34Z1BX, and the nominal sensing distance is 4 mm from the datasheet, and the usually ambient temperature variation is 0 to plus 20 Celsius, and the object material of the sensor that will be detected is stainless steel screw, and the assured sensing distance formula Sn times k theta times km times kd times kt, and firstly is k theta, where we get 0.98 based on our ambient temperature variation, and we get it from the graph. Next is km equals to 1, where we get from the graph correction coefficient, because we used stainless steel material. Correction coefficient is usually kd equals to 1, and correction coefficient kt is usually also 0.9. So after calculated it, the correction of distance sensor is 3.53 mm.
Next, for power supply selection, we choose AC to DC power supply, which is a 34 volt output and 5 ampere output. The volt which is here based on the data sheet of the motor here. The motor needs 34 volt power to move the motor. Next, after we have done with the calculation, then we design our automatic storage rack with the dimension. So we can see here the outside view of automatic storage rack. So this is a isometric view, top view, side view, front view. From the isometric view, you can see here it has two rack that can be stored left and right, and then it has a box here, and then user will put their belonging into the box, and then the platform here will move into the rack here. This is the inside view of the automatic storage rack. You can see here this is the main platform in the between of the two rack that will move in the horizontally and also vertically. All the dimension here are based on the calculation that we have done before. Next is the component that we use for our project. First is a motor A that will move the timing belt here to the horizontal axis, and then the motor B that will move the timing belt here that connect to the platform, so the platform will be moved in the vertical axis, and this is motor C that will move the platform into the rack. So we can see here also the cylindrical aluminum beam that will support the platform here, the storage rack, the storage box that will be keep in the rack, and then this is the drop point for the user to put the belonging, and then this is the save button to save the belonging, and retrieve button to retrieve back the belonging, FID card sensor to scan the user's cards, and then we will put a inductive sensor on the platform here for detect the power screw at each of the column and row to save at the correct place. Next, this is a progress before COVID-19. We have done some part of the platform, the rack here, and also the moving part here. And then this is a electrical component that I managed to bring back to my house. So we use this is the FID card sensor, inductive sensor, Omega, push button LED, motor A, motor driver and power supply, and the motor B. Unfortunately, I don't have a motor C, so I will show you later how motor A and motor B works. Next is the sequence to store the item. For the coding part, I'll manage to do only how the platform here store the user item into the box here. So all of this I will explain after this, how the platform move to store the item in the rack. This is basically our automatic storage rack system for IDP this semester. The automatic storage rack has two racks to store the item, which are in the red color, and each of the rack has 4 row and 4 column to store the box like this in each of the cell in the rack. Next, the automatic storage rack has 4 input. For now, it only has 4 input, which are yellow push button to store the items, green push button to retrieve back the item, RFID card scanner to scan the RFID card, and lastly the inductive sensor to sense the metal or the power screw that we will put on each row and each columns to make sure the correct place for the platform to store the box. And in the middle of the automatic storage rack, there is a main platform that will move horizontally or x-axis, vertically or y-axis, and lastly z-axis that will move into the cell in the right. So how the main platform works is very easy. For example, the user want to store the box in the third column and third row. After the user put their belonging into the box and push the yellow button to store the item and scan their RFID card, first the platform will move in the horizontally to find the right column by sensing the metal or the power screw in each of the column here using the inductive sensor. So the motor here will move the platform in the horizontally in the first column. It will sense, the inductive sensor will sense the screw at the column, but we will stop here because we want to store in the third column, so it will still move until here. After it sense, after the inductive sensor sense the power screw here, the motor for the x-axis will stop. Then the motor for the y-axis will start to move to find the third row. Same goes to the row. The inductive sensor will sense the power screw in each row until the third power screw is sensed by the inductive sensor. So the motor for the y-axis will stop. Next, the motor for y-axis will go up a little bit, and the motor for the z-axis will move and push the box into the cell like this. And then the motor for the y-axis will go down and put the box in the right cell. So for more understanding, I will show you a simulation with the electrical part to store the item in the third column and the third row. Firstly, to store our belonging, we push and hold the yellow button and then take a RFID card and scan it. The x-axis will start to move, and then the inductive sensor will sense the screw for the first column, second column, third column. The x-axis will stop and the y-axis will start to move, and it sense the first row, second row, third row, and the y-axis stop. Unfortunately, we don't have the motor for the z-axis, so we only show y-axis and x-axis only. And then the y-axis will start to go down, and it will sense the third row, second row, first row, and the x-axis will move to go back to the origin, third column, second column, first column, and then it will stop.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Naim Ghazali. So today I would like to present you about Internet of Things that we will use in our product. So we use the Blink application, which is this is our layout for Blink application, and we use LCD screen, uh, LCD screen and notification and email. So when we use our product, we receive the notification that say that welcome to automated storage rack, and also it look like this, and also we receive the email that was sent by the product. It say that welcome to automated storage rack, and when our item is stored at the particular slot, we will receive also the email that our item successfully stored in at the slot. So that's all for the IoT. I would like to show some simulation about this IoT. Before that, I would like to show some our coding for the IoT. This is for when we start our product, we will receive the email like this: welcome to automated storage rack. And also when we push the button, the yellow button, we will receive notification to our apps, to our phone, that say that storing in progress. And also when the belonging is reached at the particular slot, at certain slot, we will receive the email that say that your belonging stored at the slot. So that's all for. So right now I would like to show a simulation about how our program work. So this is our layout, our design. Since the software doesn't have a RFID card, this is the thing that I managed to do. So we will look what happened to this application when I press this button when I start the simulation. The application say that when the application online say that we receive the LCD say that automated storage rack, and also we will receive the email, welcoming email, say that welcome to automated storage rack. And when I press this button, our program will do the simulation, and we run the coding, and also the belonging we store at the place. Since there is no RFID card, I just can say like that. So when the item is stored at the place, we will also receive the email. For some reason, I only receive the email for
Okay, I hope you can understand what we have presented to you for presentation 1 for IDP this semester. Okay, that's all for our presentation. Thank you.
Less.